Today we'll be teaching a very important subject of energy production and waste management. Now, with an increase in population of people, the increase in industries, there is a high demand for energy. And with high industrial production, there is increase in waste. And then there is a demand to dispose this waste properly. An improper disposal of waste can cause environmental hazard. Therefore, before me you see is a setup of anaerobic digestion for the production of biogas. Biogas is an alternative source of
bioreactor. The bioreactor has 4 openings. The first opening is at the top here for our thermometer. The second opening is is also at the top, which is the one where we put our substrate inside. And then we have another opening here where the pipe goes into the cylinder, making a upward delivery and downward displacement. Then we have another opening here. Here we have a tap head. Here we take little quantity of this of liquid inside the bioreactor and then run our pH to know the pH of the pH inside the reactor. The volume of gas that is released through this pipe into this gas cylinder is equal to the amount of water that is displaced inside the gas inside the cylinder. And as a result, when we know the amount of water displaced inside the cylinder, we know the amount of gas that has been produced. Now, before we pour the substrate inside this bioreactor, we had actually mixed it outside inside a container, mixed it properly, and then we added an amount of water as stipulated down, and then we mix it properly before we now put it inside and then seal it with epoxy gum.
Hydrocarbons are not renewable, but biogas is a renewable form of energy. Recently, we had an increase in energy demand, and as such, there will be increase in overall price of commodities that are produced. So, the setup for biogas reaction helps you to produce more energy and reduce waste in the environment. Before me is a setup, like I said earlier, of anaerobic digestion of biogas, and this is our bioreactor. The temperature, with the thermometer for checking temperature. This pipe is the one which to collect the gas, and here at the front there is the tap for testing of pH. Now, some of you might be wondering, why are we doing this setup outside and not inside the lab? And that's because we need temperature. Temperature is very, very important when you are carrying out an anaerobic digestion. Go through the whole process on parameters. So I begin to check the parameters. You go with me step by step and go through the whole process. First of all, our temperature is 30 degrees Celsius, which is very key. It's very important. We don't have too much temperature, as a high temperature will harm the microorganisms that facilitate this process. Now, our temperature is 30 degrees, which we are noting it down. It's 30 degrees Celsius. So we'll take our pH now. Here is our distilled water. We'll first put the pH meter in our distilled water. After putting in the distilled water, we'll use so you see this is buffer 7, which is neutral. We'll calibrate our pH meter to 7, which is neutral. So you see, when you want to read the pH, you open the tap, you take a little of the liquid inside the bioreactor. So you see, you open the tap, you take a little of the the liquid inside the bioreactor, close the tap back, and then put our pH. See, put our pH, and the pH is reading 6.1. So that's the